Okay, we're going to continue our work with factoring with these notes on factoring trinomials. So we're going to look specifically at factoring trinomials when they are in the form ax squared plus bx plus c. This is standard form. Now remember from 6.1, when we factored with a GCF or by grouping, we were essentially working backwards through the distributive property. And that's what we're going to be doing in these notes as well. But remember, when you multiply two binomials together, we use the distributive property and then combine like terms. And the end result is usually a trinomial. So even though when we first multiply two binomials, we get four terms, the middle two often combine. So part of what we'll be doing in this process today is reversing that combining like term step to figure out what the four terms were. So as we work through these, it is important to remember that standard form of a quadratic, or really any polynomial, the highest degree comes first. So for a quadratic expression, which again is degree 2, which is a trinomial, we have ax squared plus bx plus c, where a and b are coefficients and c is a constant. So when you hear me refer to a times c or b, we're talking about these numbers. A and b are the coefficients of the first two terms, and c is the constant. So here's how we actually go to factor a trinomial, and we're going to be using a factor sum table method. And so we make a chart, and what you want to do is look at your trinomial and multiply a times c. So that's the first coefficient times the constant. And so in this example here, it would be 2 times 20, which is 40. And we're going to make a table with that product, and we're looking for factors of 40 that will add to the b value, which is 13. So depending on your numbers, this might be easier or harder, but the best suggestion I can make is to just start listing factors of the product, 40 in this case, and then see which ones add up to the b value. So 40 is 1 times 40, 2 times 20, 4 times 10, and 5 times 8. I think that's it. Now we want to find a pair of these numbers that add to the middle value, which is 13. And if you look through these, 5 and 8 are our numbers, because those add to 13 and multiply to 40. So what we need to do now is split that middle term, split that 13x into those two numbers. So 2x squared plus 5x plus 8x plus 20. And so what we've done now is we've turned our trinomial into a 4-term polynomial, and now we can factor by grouping, which we learned in the 6.1 notes. So what we did here is essentially reversing the combining like terms step of a distributive property problem. We're just working backwards through that process. So now we can factor by grouping. So we're going to find the GCF for the first two here, first two terms, which is just an x, which leaves us with 2x plus 5. From the second pair, we can take out a 2. Well, we can take out a 4, actually, which leaves us again with 2x plus 5. And remember from the 6.1 notes with grouping, you want this to be the same. So that's 2x plus 5. And then what's left over is x plus 4. And there's the answer there. So that is the process. It is mostly the same as the work we did with grouping, we've only added a first step of splitting the middle term and undoing the distributive property in order to get us to a point where we can actually factor by grouping. So let's try some. Now these first four have, the first part's been done for us. So we're looking at example 1a here. We have 2x squared plus 7x plus 3. And we want to find two numbers that multiply to 6. 2 times 3 here is 6, but add to 7. And you can see from the table, they've done that. That's 1 and 6. Those numbers multiply to 6 and add to 7. So we're going to split that middle term. We'll have 2x squared plus 1x plus 6x plus 3. So we've split the 7x into 1x and 6x. We undid that combining like term step, and now we can factor by grouping. So from the first two, we can take out just an x, leaving us with 2x plus 1. And then we can take out a 3, so plus 3. Divide those by 3, we get 2x plus 1 again. So our two factors are 2x plus 1 and x plus 3. Let's go on to the next one. Example B. Again, we see it's been done for us. We're looking for two numbers that multiply to 16, 16 times 1, but add to negative 8. Now, when you have a positive product but a negative sum, your two numbers must be negative, because two negatives multiply to a positive, but still add to a negative. So our two numbers here are negative 4 and negative 4, because those multiply to positive 16, but add together to negative 8. So now we split that middle term, positive 16w squared minus 4w plus 1. So make sure you also include the variable on those. We're splitting the negative 8w, and so they both need to have a w on them. And now we can factor by grouping. So we'll take a 4w out of the first set here, leaving 4w minus 1. Now, we want this to match. We want to get 4w minus 1 in this second set of parentheses. So what we have to actually take out from these two is a negative 1, and that will turn that negative 4w into a positive 4w, and the positive 1 into a minus 1. So now we've got 4w minus 1 here. We actually have 4w minus 1 right there. So our two factors were the same in this problem. 4w minus 1 times 4w minus 1. Alright, example C, it's been started for us. So 6 times 4, that is 24. And we're going to add to 11. So we're looking for two numbers that multiply to 24 and add to 11. So if we just start thinking of or listing the factors of 24, it's 1 and 24, that's not going to work. 2 and 12, nope. 3 and 8. There we have it. 8 plus 3 is 11, and 8 times 3 is 24. So 3 and 8 are the two numbers we should use. So again, we're going to split the middle term here. So we'll have 6x squared plus 3x plus 8x and then plus 4. So we just changed that positive 11 there into 3 plus 8. And now we can factor by grouping. 6x squared plus 3x, we can take out a 3x there. That leaves us with 2x plus 1. From 8x plus 4, we can take out a 4. And that again leaves 2x plus 1. So there's your first factor, 2x plus 1. And what's left is 3x plus 4. All right, moving on, example D. We're finding two numbers that multiply here to 5 times 6 is 30, but add to negative 17. Now, so again, we have a positive product, but a negative sum. So our two numbers are going to have to be negative. So negative 1 and negative 30, that multiplies to positive 30, but does not add to negative 17. Negative 2 and negative 15, there we go, that'll work. So 5m squared, and then we're going to split that negative 17 into the negative 2 and the negative 15. So minus 2 mn minus 15 mn, make sure the variables match, and then plus 6n squared. Now just a note, it doesn't matter what order you write those two numbers in. I could have written 5m squared minus 15mn minus 2mn plus 6n squared, and my grouping step would look a little different, but my answer would eventually be the same. So you can write these two numbers in whichever order. Okay, we're going to take out, looks like just an m from this set, so that leaves 5m minus 2n. From the second set, we can take out definitely a 3n, but again, we want to match up the positive and negative signs. So we want to get a positive 5m minus 2n, so we'll take out a negative 3n, and that will give us a 5m minus 2n there. So there's your two factors. We've got 5m minus 2n, and the leftovers, which is m minus 3n. All right, let's keep going. Next page. Got a few more here. A couple notes. First of all, whenever you're factoring, you always want to check for an overall GCF that you can divide out of the entire thing. Will definitely make things easier for you. Also, keep in mind that if a polynomial cannot be factored, it's prime. So if we go through all of our possible options for the product, for the factors, and none of them add to the correct number, chances are our polynomial is prime. But that's pretty rare. It doesn't happen a lot, so make sure you really check all of the numbers before you decide to say that it's prime. Okay, let's try these. So we're looking for a number here, for example, a. Multiply a times c, so 3 times negative 3. That's negative 9. So we're looking for two numbers that multiply to negative 9 and add to negative 8. So I know 9 and 1 can get me there, but the sum is negative 8. So I want the 9 to be negative, because negative 9 plus 1 is negative 8. So now let's split that middle term. 3y squared minus 9y plus 1y minus 3. Now we can factor by grouping. We'll take out a 3y. So what's left over here is y minus 3. In the next set, we can just take out a 1, and that does leave us with y minus 3. So the answer here, first factor is y minus 3, and the next one is 3y plus 1. So split the middle term, factor by grouping. Looking at example B here, we can see there is an overall GCF. We'll take it out. It is 3, and that will leave us with 2r squared minus r minus 3, which is going to make things a lot easier. So first we want to multiply a times c. That's 2 times negative 3, so negative 6. And our sum is negative 1. So, if you try 1 and 6, no matter which one of those you make negative, you won't get negative 1. Let's try 2 and 3. There we go. If we make the 3 negative, negative 3 plus 2 is negative 1, so that does work. So let's split that middle term. 2r squared plus 2r minus 3r minus 3. So again, we just split that negative 1r into 2 minus 3. So we didn't change anything. 2 minus 3 is still negative 1. We're just rewriting it so that we can factor by grouping. So out of the first two, we can take out a 2r, which leaves 1r plus 1. And then we can take out a negative 3 from the second two, and that will again leave us with r plus 1. So first term here is r plus 1, and left over is 2r minus 3. Okay, last three. First, find AC. AC here is 24. So we're finding two numbers that multiply to 24 and add to negative 11. Well, since the sum is negative and the product is positive, we know both of our numbers have to be negative. So negative 1 times negative 24, that's not going to add to the right one. Negative 2, negative 12, same thing. Negative 3, negative 8, however, that works. Now, this table that we're writing, this 24 with all the factors, if you can consider the product here, 24, and the sum, which here was negative 11, and if you don't need to write the table down, that's okay. If you can do it without it, feel free. It is just a very helpful way to organize things and to write down and eliminate factor pairs that you know are incorrect. So split the negative 11. We've got 2x squared minus 3x minus 8x plus 12. And so we will factor by grouping now. We can take out an x. So that's 2x minus 3 left over. Again, we want us to match up, so we have to take out a negative 4, and that leaves us with positive 2x minus 3 again. So our answer here, 2x minus 3 and x minus 4. One thing I forgot, just realized on example B right here, don't forget, like I forgot, you need the 3. If you take out a GCF at the beginning, make sure you include it in the answer as well. So make sure you write that down if you didn't the first time through. All right, back to example D. We have to find AC, so that's 1 times 12, which is 12. So we need two numbers that multiply to 12 and add to 8. I think I already know 1 and 12 won't work, but 2 and 6, that will work. So we're going to split that middle term. So 1k squared plus 2k plus 6k plus 12. And again, you could mentally check that. 2 plus 6 does equal 8. So we haven't changed anything, we just rewrote it. Now we can factor by grouping. Take a k out of the first two, so that's k plus 2 left over. Then we can take out a 6. And again, k plus 2 is left over. So our two factors here are k plus 2 and k plus 6. Last question. We've got 4w squared plus 8w minus 3. So we are multiplying here to negative 12. And we want to find two numbers that multiply to negative 12 but add to positive 8. Now since our product is negative, we'll need one negative and one positive, right? So let's try these. So 1 and negative 12, that does not add to positive 8. Also, since our sum here is positive, the bigger number needs to be positive. So negative 1 and 12, although that doesn't add to positive 8 either. So we can try 2 and 6, so the 2 would be negative. 6 plus negative 2, though, that's 4. And if we switch that, 2 and negative 6, that adds to negative 4, so that doesn't work. All that's left here is 3 and 4, so negative 3 plus 4 is positive 1, and even if we switch it, 3 plus negative 4 is negative 1, so that doesn't work either. So this polynomial, this trinomial, is actually prime. Cannot be factored. Since this process of finding those two numbers didn't work, we looked at all of our options, and we just simply could not factor this at all. We can't take a GCF out of it, so there's nothing we can do. This is a prime polynomial, which means it does not have any factors apart from itself and 1. Apart from that, though, this is the process for factoring a trinomial. Find the product AC, find two numbers that multiply to AC and add to B, split the B term, the middle term, into those two numbers, and then factor by grouping.